My name is Joe Saavedra. I'm here from Parsons, the New School for Design, New York City. First of all, I'd like to say it's an honor to be presenting my work at Design Indaba. I'm extremely excited. So Citizen Sensor was my master's thesis project. I've been working on it for the last year and a half. It's a DIY open source wearable pollution monitoring and data collection system. So you guys can remember that later on. But first I want to go through a couple projects that kind of led me down that path. So my first year, my master's program, I began to discover physical computing, which is this area of programming microcontrollers and embedding them into objects. So this is the Spatialized Umbrella project was basically created a very personal, immersive audio and visual experience. It had range sensors that detected your movement through space and then played sound through the umbrella and also LEDs flickering. It was exhibited at a festival in Belgium last year and was my first kind of project with embedded computing. The next one I'm going to show you, SOBEaR, it combined two of my favorite things, I'd say robots and alcohol. It was a stuffed panda bear that had an alcohol sensor. You would press a button. This is just a little excerpt from a video. You blow into its face. It measures how much you've consumed already and then pours you a responsible drink, depending on how much you've had. So in this case, he had only had 2 drinks. The robot decided you should have a nice full shot and then have some mixer in there as well. The last project I'm going to show you is an EKG-controlled Game of Life hoodie. I made this last year. It's a sweatshirt that has a matrix of LEDs embedded into it that are constantly playing Conway's Game of Life. I'm not sure how many of you are familiar with Conway's Game of Life. It's kind of a nerdy concept. It's it's a zero-player game, basically cellular automation controlled by an algorithm invented by a mathematician in 1970, John Conway. But what's special about this hoodie is that it's also checking your heartbeat, as you can see in the center. And each time your heart beats, it resets the game. And so essentially, your life is controlling the game of life. For a nerd, very, very poetic. I liked it a lot. Got some attention online. So to Citizen Sensor, which I've been working on for the last year and a half, the concept kind of broken down into 3 actions would be collecting data about your environment, about your personal space, then sharing this data. Obviously the internet is the fastest and most effective and cheapest way to share anything at this point. And then learning from those numbers that you're getting. So the first thing I had to design was actually how this is going to work, how the system actually will function at all. Like I said, physical computing was something I got into. You've got a sensor pack. The sensor pack has different sensors measuring whatever you pick and choose to sense. A Bluetooth antenna pairs with an Android application. The Android application is sending your data to the cloud, and then from the cloud we can actually get it to come down wherever we want. Maybe it's to a mobile application, maybe it's to a desktop web application. So I'm just going to really quickly go through some prototypes. Originally I was using SD cards to write everything. I like this DIY. DIY and open source are two concepts that I have taken extremely seriously since my graduate studies. I like this Tupperware first enclosure for my sensor units. And you might have noticed there were some USB ports there where you can attach sensors. Modularity I thought was an important aspect of the project. It let people choose what they want to sense and when they want to sense it. Maybe they want to swap out carbon dioxide for a dust sensor, right? Depending on their application or what they're interested in learning about. Again, I documented a lot of processes I kind of tweaked. This is a printed circuit board that I made using a laser cutter, which is really unusual. It's a pretty in-depth process, again, all published online, all documented for people to replicate. So I was pushed finally, once I got working prototypes, I was pushed to kind of design the product, right? Make a beautiful design. So I worked with some product designers, I learned a little bit of CAD, and this was kind of the most beautiful final design I came up with. As you can see, the sensors are embedded in these little enclosures that you could plug and play as you wish. Here's some more pictures of that prototype. And yeah, so wearability. Why is wearability important? A passive interaction is very different than an active interaction, right? It's very different if you go around saying, okay, I want to read data right now, I want to read data right now, a bus is passing by, I want to read data right now, versus a passive interaction of data constantly being collected. It makes obviously a larger data set, which is less biased by your thoughts as you're walking around, and then we can get much more meaning extrapolated from that data and learn actually much more meaningful things from that data. So next. So I had to make it wearable. I started working with kind of lanyards and armbands, and then with that final prototype, a clip that could go on your bag, anything in your personal space. And I need to start thinking about who's going to use this kind of system, who might be interested in this. Here's four potential. I ended up going with the educational, the top one. I ended up going on the educational route. And that was actually a really amazing project. I got to work with the New York Hall of Science on a program last summer. I developed curriculum. We developed the system to be used for kids to go around and actually collect data in and around Corona Park in Queens, New York. And it was a really amazing experience. Obviously, the Android application went well. Here's a picture of Corona Park in Queens where they had collected data. This is Google Maps visualizing it. Here's an augmented reality application showing the data that they had collected. It's called SOBEaR. It's really excellent. So I was fortunate enough, I'm really happy to say last October, I won the Cologne International Design Prize. And with that money, I've been developing the system further for public release, hopefully. Thank you. So actually right now you can already order this kit, for example. I completed, this is specifically just for one carbon monoxide sensor, but then hopefully the entire project will be available soon. Just to summarize kind of what I'm doing, I know I went through some kind of technical stuff. I want to empower the world, I want to empower people to be able to learn about their environment on their own terms. And I think that's something that we don't have. I mean, there's data out there, but I know at least in terms of New York City, the World Health Organization has numbers that are years and years old, and who knows how accurate that is for your neighborhood. So I'm all about empowering people, and hopefully this excites you as well. Thanks a lot, guys.